Let me find a video to play. What track? Suzuka is what we have next, actually. Yep.
Hi, I'm Matt Mellis.
This is what you get today.
I'm an aerospace engineer for
All right.
NASA.
I'll be back in a little bit. We'll do space news on the other side of this.
Years. And I'm here with my colleague today, Kevin Burke, who participated in the acquisition and deployment of the 30 or so clips that you're going to see in just a few minutes. Now, and Kevin, thanks for being here today.
Glad to be here, Matt.
What you're going to see is what I consider to be the best of the best state-of-the-art imagery on both film and high-definition video that the Space Shuttle program is capable of producing today. And not only does it serve a technical purpose, and we'll get into a lot of that detail as we get into the movies here, but it also serves as an enormous inspirational and educational aspect for all of NASA's stakeholders. There's a number of intents that we have for this production, and one of them is to pay tribute and commemorate the shuttle program, which has essentially been a 30-year program, and it's nearing completion as we go to final print with this production. We also want to pay tribute to the men and women that made all of this imagery possible over the years of different missions and launches that we've had. And also to give a view that not very many people see outside the NASA family of these fantastic pictures that are used largely for engineering purposes, and to let everyone on the outside of the NASA family have insight as to what goes on with the shuttle when it launches. I think this is a very moving set of clips that you're about to see. We're opening here with this somewhat stylized view of one of the launch sequences that actually is going to play out in the upcoming clips. And I've got a little soft focus on it, and thought we would open it up with a couple of fun facts about the shuttle. It really is an amazing piece of equipment. It has phenomenal amount of fuel that it burns over the 8 minutes during its trip to orbit. And when they get up there, in that short 8 minutes, they're going about 5 miles a second, which is a pretty spectacular achievement for a piece of machinery. So this is how it all happens. This is how the machine does its job, and the film speaks volumes.
This is camera view E19. We commonly refer to this as Echo 19. And it's a 16 millimeter camera with a 10 millimeter field of view for the lens, the focal length of the lens. And it's running at 400 frames a second. So the effective shutter speed is really 1/1200th of a second.
Yeah, it's pretty amazing. I mean, this is all a slow motion event. And basically you're going to see the 6 seconds prior to launch of the vehicle as the Space Shuttle main engines turn on. Now, the purpose of this camera, they all have different purposes. Most of these, if not all of these cameras that you're going to see in this production are engineering cameras to look for different engineering aspects of the launch process. And so the purpose of this one is to check to make sure ignition is going off okay, which is what you're seeing here. Main engine start is just happening, and you can see the engines are starting one at a time. This particular camera looks at engines number 1 and 3, right? Is that what this is?
Yep.
And so you can see them, they're starting to fire up. Those sparkers that you see are there to make sure that any unburned hydrogen gets ignited before it floats around and collects in some place where it can ignite later and cause problems. Again, you're seeing the engines sort of turn on here. And so we're roughly coming into about 5 seconds before liftoff. The computers are checking and validating that everything's A-OK. And there's a little bit of a pitch over that the whole vehicle does as a consequence of these engines thrusting off the center of gravity. And when the whole vehicle snaps back and is straight up in the air, the engines or the boosters ignite and the whole thing takes off. great photography here. I mean, you can see all this flow phenomenon going on inside the engines. Now, the space shuttle main engines are burning hydrogen and oxygen, and I'll talk about some of the fun facts about that later on in some of the other clips that you're going to see. But here you can see the engines have stabilized, and everything is A-OK. And in just a few moments, you'll see the boosters fire off. Did we talk about the time code? I can't remember. So.
No, we haven't talked about the time code. The time code that you'll see, the LED display on the right-hand side, is actually positioned between the two sprockets on the 16 millimeter frame. And the time code is UTC time code. It's an IRIG-B format. And you'll see that it's 21 hours, being UTC at 5:02 p.m. local time, 2 minutes, 11 seconds. And the three digits that are moving in the upper right-hand corner would be representing a thousandth of a second. The solid number 1, the second digit from the top, is indicating the synchronization of the camera as more of a technical parameter. And that is on every camera to synchronize the field of view, synchronize the time.
This is pretty cool. You can see some of the oxygen, that cloud of vapor there was from the oxygen fuel umbilical. Of course, the solid rocket boosters have now ignited, and the whole vehicle is lifting off the pad. And you can see sort of the glory of this moment. I mean, there's an enormous amount of fuel being burned. One little thing that I love is if you look at the sky in the background, and this was a very clear day. These pictures were selected, or these movies were selected because of the wonderful photography that we got on this day. And you can see the sky deep into this dark blue, and that's because, as Kevin will talk later on, that we got into color correction that we do post launch to make sure that we're capturing all of these the events that are going on, all of the flow events. So here the vehicle is clearing the pad, and we're on our way.
This view that you're seeing here is camera E8 or Echo 8, and it's a 16 millimeter camera with a 10 millimeter lens.
Yeah, you can see the boosters now coming off the pad, and one of the amazing things that a lot of folks don't know about the shuttle is bolted to the mobile launch platform is it's basically through 4 bolts on each solid rocket booster. And the intent of these cameras is to watch that bolt, which is an explosive nut bolt arrangement, and the bolt weighs about 100 pounds, I should say. And these nuts fracture and the bolts slap down into a holder that you're actually sort of seeing in the foreground here, and they literally release the vehicle from the pad and allow it to take off. So for obvious reasons, we have a camera on each one of these explosive hold down posts, and to make sure that they're operating, they're a critical aspect to the launch process. We want to make sure that they're operating good. So you can see that puff of smoke coming out, and actually if you want to put the remote on a frame-by-frame stop action, you can actually see the flash as it explodes. Now, Kevin, here's where you guys really did a fantastic job of capturing the detail in the plume through this automatic aperture on the cameras. You want to talk about that a bit?
Sure. Many of the 16 millimeter cameras that are on the MLP and pad structure have an automatic exposure control. It's the only real way to keep the exposure, the high dynamic range exposure from pre-ignition of the SRBs through the liftoff out of the frame of view. So the camera has basically an automatic exposure.
Right. Now look at the sky on the left thing, and see how it gets dark. Actually, on both sides, you can see how it turns that deep blue. That's the automatic aperture in action right there, right?
Allowing it to see the detail in the pad structure and also in the flame.
Yeah. I mean, when you see a launch in real life, you can't see any detail with the naked eye in the plume. It's just like looking into the sun almost. It's so bright. We can see some of the water from the launch pad. There's a cooling water that comes out. We'll talk about that later. That's splashing onto this quartz protective glass that the camera's behind. Of course, they're in these explosion-proof containers, right, to keep the cameras safe and sound. Cameras were harmed in this in the making of this movie.
That's right. The cameras are in an explosion-proof box, which is nitrogen purged, and the quartz glass on the front protects the lens. In most cases, there are some cases where there's damage, and if that's the case, the lenses will be repolished, reground, or whatever's necessary to bring them back into optimal condition. Well, Matt, this next view coming up is Echo 18 or Camera 18, and it's a 10 millimeter lens and looking at the TSM or the tail service mast carrier disconnect.
Yeah, the umbilicals, there's one on each side of the orbiter, one for the liquid oxygen fueling and one for the liquid hydrogen fueling. Those are primary purposes. You can see there's a lot of other instrumentation on these things. in feed lines. But these cameras, their intention is to make sure we get good retraction of this. And there's actually a huge 20,000-pound mast that pulls these things inside the tail service mast for the door to slam shut and protect them from the hostile environment on the outside. Now these umbilicals are about 4 feet wide by 6 foot tall, so you don't really get a sense of scale when you're looking at these in these movies. But they're as big as an average-sized human being, so they're quite large.
One of the interesting photographic challenges that we run into in photographing the TSM carrier disconnect from the inside of the tail service mast is once that door closes, it's pitch black in there. So there's a set of series of tungsten lamps that provide illumination, and the vibrations, the tremendous amount of vibrations that are induced during the liftoff, really rattle those lights, and keeping them from having those bulbs break has been quite a challenge. In fact, they are in the process of changing those lights over to the new LED arrays that provide more stability and less frequency of having the bulbs go out before the film runs out.
They're a lot more robust to that kind of environment.
Okay, Matt, this is Echo 001, and this is one of the 4 cameras on the edges of the MLP deck. This camera happens to be on the northeast corner of the MLP deck, and it's a 16 millimeter camera, as all the ones on the MLP are, and 10 millimeter focal length. It's a wide angle view, and the effective shutter speed is about 1/1200th of a second.
For our viewers, you can see that we pulled a little bit away back from the vehicle now. We're taking a little bit of a wider view. There's the SSMEs just firing off there, and you can see the plume in the background growing. In fact, if you look carefully against the plume there, you can see a couple of cameras. Why don't you mention what those are, Kev?
Those are some MOTV cameras, operational television cameras that are used for surveillance of the vehicle. They and are piped back live to the launch control complex. The signals.
So the SSMEs are firing. You can actually see the launch tower on the right-hand side of the screen. And again, they go on for about 6 seconds. Computers are making sure that everything's working. And at T-0, those boosters are going to fire, and you'll see a big puff of smoke come out of the flame trench there, and it'll get sucked back down in as the boosters come off the pad. And these two sort of structures, one standing just to the left of the left booster and one standing just to the right of the right booster, are called rainbirds. And there's some piping sort of flat against the launch pad as well that sort of connect all these things together. There go the boosters firing. And all of this fresh water, 300,000 gallons to be exact, comes pouring out of those rainbirds and onto the launch pad to deaden the acoustic noise and cool the pad down. So that's where the water comes from on some of these camera shots.
And here you can see the AEC, the automatic exposure control on the cameras taking over as the booster plume comes into view, and allows to see the AEC allows you to see the detail both in the plume as well as in the vehicle and the structure itself. And you can also see very good detail on the deck of the MLP.
Now, we talk a little bit about the purpose of each one of these cameras, and this one is to look for some structural anomalies on the vehicle, some thermal insulation failures we might have on the tiles or the blankets, etc., and how the water is getting dispersed on the pad. And also we're looking at debris, and actually you can see here that we've got quite a bit of debris in the field, and debris is a big concern for the shuttle folks, and we want to keep an eye on it to make sure we don't have anything that's going to threaten the vehicle.
Now, Matt, you can see that this is this is camera Echo 4, E004. It's on the corner of the MLP deck, and very similar in field of view to the camera we just looked at. One of the things I like to point out is you can see one of the camera box enclosures we were talking about a little bit earlier on the left-hand side of the frame, right in front of the left SRB.
Yeah, and in fact, as we mentioned earlier in the piece, there's about 125 cameras or so, actually more, that document any given launch. And so, for brevity in this piece and to make it watchable, we had to have a lot of film hit the cutting room floor, and it was really difficult for me to cut a lot of it out because I loved all of the footage. I'm a fan of each and every camera, but that little camera there didn't get its day in the shade. That film of the booster had to. We'll have to have that for the director's cut in the future.
And just to give you a perspective, this camera originally captured this scene at 400 frames a second. So it's being played back at 24 frames. So it's about 1/16th of the speed that it was actually captured at, to give us a real-time view.
Now you can see here how absolutely gorgeous the day was, and as we mentioned earlier, it was about 5 o'clock in the afternoon. So in the film industry, they call this magic hour, and there's no question about it that this is one of the best times of day to take photographs of the shuttle. You have these rich colors and just a beautiful blue sky to sort of highlight all of this. So I find these pictures second to none in all of the launch imagery that's been taken. I should say that these boosters shed about 10,000 pounds of mass per second once they're lit up, and that's each, so it's 20,000 pounds combined. And you can really get the feel of that awesome magnitude by looking at these images. There you see a piece of debris on the right, sort of doing a ballet in slow motion there. This is some tie-down string from some water membranes under the SRBs that we'll talk about in a few moments. You know, teams go through this. This is engineering footage, and the teams go through this and identify everything they see in it.
Okay, this is camera Echo 36, and this camera is located on the fixed service structure at the 255 foot level. We refer to the fixed service structure as the FSS. It's a 16 millimeter camera with a 16 millimeter focal length lens. And the effective shutter speed is about a 1/1200th of a second, similar to some of the other ones that we've seen.
This is a long clip. In fact, this is probably the longest clip that I sort of chose for the production. There's a lot going on in here, but it looks a little boring for a while because those engines are on for a long time. So we're still at 400 frames a second here, right?
Yes.
Yeah, okay. So there you see the main engines igniting. You can see all of this water pouring into the flame trench. There's the big flash, the hydrogen and the oxygen lighting up. I should tell you that coming out of that external tank, inside there, the cryogenic propellants, liquid oxygen, liquid hydrogen, 750 gallons a second of liquid hydrogen is pouring into that engine cluster, and 280 gallons a second of liquid oxygen. All of these things being combined instantly, effectively instantly, to create this fantastic combustion process, burning 3,000 pounds of propellants to turn it into water vapor every second. And it's almost invisible when it comes out of the engines. So the engines are turning on now, and you can sort of see them glowing against the water pouring into the flame trench. That water's there primarily to deaden the acoustic noise and to keep things cool. And you've got a good look at the belly of the orbiter here. One of the purposes of this camera is to look to see if we lose any tiles due to the shock of ignition of the solid rocket boosters. Now, you're going to see the boosters turn on in just a couple of minutes, and you see those red sort of ribbed surfaces there inside the flame trench. Those are actually membranes to hold water, and those will get burned away, and you'll sort of see that in the film when the boosters fire. There you see them right there, and there's water in there that's sort of getting jarred loose and turning into steam. And I'm assuming, I don't know for sure, that it prevents sort of a recirculation of the exhaust at liftoff. Probably, again, acoustic deadening noise. And there you see those boosters firing off. If you look in the upper left-hand corner, you see the umbilical falling backwards there. And then look at how the space shuttle main engines are punching through that water in the flame trench. That's really cool.
Yeah, it is quite a dramatic shot, and you can see the auto exposure control on the lens, as we've talked about on some of the other views, really helping to be able to see the detail on the SSMEs punching that hole, as well as looking at the plume from the SRB, and seeing the edge of the belly of the orbiter too.
See, the SSMEs aim a little bit off kilt there, and you can see them hitting the upper part of the mobile launch platform as they rise off. Amazing that they capture all that detail in the SRB plumes. It's good stuff. It's a fantastic clip. It really is.
This is camera Echo 41. This is on the fixed service structure on the FSS at the 255 foot level. It's a 10 millimeter focal length on the 16 millimeter camera. It's a really interesting view, and Matt, you want to provide some more details about what we're seeing.
Yeah, you can see the boosters have already fired, and this big umbilical structure that you see swinging back is actually very massive. The plate on the end of that is about 1.5 by 3 foot square. You'll see a close-up of that in a little bit. That's the ground umbilical to hook up to the venting for the hydrogen tank, and it's got some nitrogen and helium purge lines and some instrumentation to go with it. Pretty complicated structure. You get a picture of that in a minute. If you look at the MLP, or the mobile launch platform, you'll see all the water coming out of the rainbirds under the launch pad. And again, our active exposure kicking in there and giving us a great shot of the plumes as the vehicle clears the tower. Look on the right, you can just see a tad of the SSME burning there, that little blue cone. Fantastic detail there, isn't it?
Yeah, it's a great shot. Echo 40 is one of my favorite shots, Matt, and this is on the fixed service structure on the FSS at the 275-foot level, just a bit higher than the two previous views we saw. And this is really an incredible view of not only the orbiter, but the beautiful ocean, the late spring day in Florida, and very nice lighting on the tank, and as well as you'll see on the orbiter surfaces.
Yeah, it truly is magic hour on this. That orange tank, for those that aren't all that familiar with the shuttle, that's foam. That's insulating foam on the tank to keep the cryogenic propellants cold on the inside. Liquid oxygen, liquid hydrogen are pretty chilly when they get into their liquid state. You can actually virtually look into the cockpit here. If you look carefully, you can see the ocean right through the window, just briefly there for a moment. Kind of fun. There's Discovery in all its glory. This engineering view is to look at any possible issues with the tiles or the thermal protection system on the vehicle. And look at that. Absolutely gorgeous. You can see some of the flakes of ice sort of tracking the vehicle as it moves upwards. Remember, as we mentioned earlier, that 3,000 pounds of water vapor a second is coming out of the space shuttle main engines on the back. It's pretty incredible, and it's virtually invisible. All right, this view is of a structure we call the GUP, which is the ground umbilical carrier plate, which attaches to the ground umbilical carrier assembly, sometimes called the GUCA. That plate is about 1.5 feet by 3 foot. It's a sizable plate. You don't really capture the scale in this, and you can see the vehicle is now lifted up and it's taking off. That umbilical peels back right at solid rocket booster separation or detonation.
And Matt, this is camera 33, and this is on the FSS. It's at the 235-foot level, and is using a fairly long focal length lens. And you can tell by the field of view that it is a long focal length lens, and it's 75 millimeters.
Now, if you look, you can see the boosters kind of surging. It's not a continuous pass. It sort of pushes and then slows down a little bit. And what you're seeing there is the natural frequency of the booster thrust. I believe it was on the order of about 7 hertz, 7 cycles a second, and you can see that go by and hear the aft skirt of the boosters going by with a really nice tight shot of the exhaust.
This camera view is on the pad perimeter. It's located at camera site 3. It's about 1,273 feet away from the vehicle, and it's the first in a series of the 35 millimeter cameras, which we'll be seeing in the upcoming sequences. There's a lens on here. The focal length is 500 millimeters or so, and the effective exposure is a 1/450th of a second, and the camera's running at 180 frames per second.
Yeah, it's a beautiful shot, and this is going to, as Kevin said, it's first in the 35 millimeter shots. They're a little better quality because they've just got more surface area to put an image on. You can see the SSMEs firing and all in nominal operation here. And as soon as they pull away from the pad, you'll see the left booster in the background, centered between the two service tail masts. And just a gorgeous shot right there, looking at the steam coming off the SSMEs. And this is a fantastic capture of what remains behind after the vehicle clears the towers. You have all of this water and steam being pushed around in this amazing hostile acoustic environment. I mean, look at what's going on there. This is all acoustic noise and shock coming from the boosters in the SSMEs.
Camera 63 is located on the pad perimeter, one of the camera sites. It's 1,270 feet from the vehicle, and it's using a 105 millimeter lens. The camera's running at 180 frames a second, and that's pushing about 630 feet of film through the camera per minute. Quite a fast rate, especially for 35 millimeter.
Yeah, you can see the sparkers going there, just getting ready to turn the main engines on. And in the background, you'll see the water tower. That's where all that fresh water comes from to flood the pad, to keep it chilled and deaden a lot of that acoustic noise that we've already seen what it looks like in the plume. Absolutely gorgeous day, really accentuated by this shot. Blue sky in the background. Goes great with the white exhaust plume coming out there. And you can see a lot of splashing and stuff jetting out from all different directions at the bottom. You'll see more of that in the shots that are coming up. This shot is going to be the first of a bunch of different views as we march counterclockwise around the pad to look at it from different angles. And there you can see the boosters have fired, and you see it all coming out the other side of the flame trench. And beautiful shot of it coming off the pad.
And the lighting at 5 o'clock in the afternoon on this late spring day is just about perfect from this camera view. Of course, it won't be perfect for all the views, but certainly is a nice angle and really illuminates the vehicle as well as the structure very nicely.
Yeah, I like when the vehicle leaves. I left a lot of these shots run long because I thought it was kind of neat to see what happens afterwards, and you can just see the whole service structure here being engulfed in steam and exhaust from the solid rocket motors.
Now, one interesting thing about this particular 35 millimeter format is earlier we mentioned about the time code. And the iRig time code is burned in with an LED display, and on the 35 millimeter format, it's actually in part of the image area because the 35 millimeter format has 4 sprockets per frame. So there's no way to position the LED time code in between the sprockets like we can on the 16 millimeter views.
Right. So if you looked at the 16 millimeter, you could actually see the sprockets at the top and the bottom of each frame, and those aren't visible in the 35 as you see here.
The camera number is on the lower right hand display of the LED time code, and it's in this case it's camera number 62. So the 35 millimeter format also allows us to put a camera designator number that's fairly often used, just to help for viewing purposes and tracking purposes. This again is a 105 millimeter lens and is on the pad perimeter, approximately 1,270 feet from the vehicle.
Look at the absolute force that all of this stuff is coming out of there. I've talked earlier in the piece about how much is coming out of the solid rocket boosters, 20,000 pounds combined, and then the SSMEs are losing 3,000 pounds of liquid propellants a second. And that really shows up here when you're looking underneath the launch platform. You can see that all of that stuff doesn't have anywhere to go, which is why it's vectored out on both sides, so it can be sort of safely directed away from the vehicle, so there's no rebounding or sort of backflow, so to speak.
And one thing we haven't had a chance to talk about earlier is how the cameras are triggered. Currently, the camera's all triggered using the POX, or the photo optical control system, which triggers all the cameras on the pad perimeter, on the fixed service structure, as well as the MLP. and it's quite a sophisticated system to synchronize and trigger all the cameras based on the launch clock.
Yeah, it's undoubtedly a very complex system to have all these cameras operate flawlessly for each launch. They're very important, if not critical, for shuttle launches, and it's an amazing achievement that all the men and women who work on this are able to do it with such a degree of reliability every launch. Another shot here is, as I said, moving around counterclockwise. You see the SSMEs, or the boosters, are just firing, excuse me, and there you see the gut falling back, as we talked about earlier, the umbilical assembly.
This view is using the same 105 millimeter focal length lens that the other two views we just looked at, and again is about 1,200 feet from the vehicles where the camera site is located.
You know, this was a really unusual day because you just mentioned earlier that, you know, from all views is the lighting going to be as good, but this is about as good as it gets. I mean, each and every one of these camera views is well exposed, both from an engineering and a beauty standpoint. They're all very, very nice shots, and it's why we selected 124 to be the predominant content in this movie. There's the water tower, by the way, in the foreground. It's just about to get engulfed with the exhaust.
This is a Dog 68. It's a 35 millimeter camera, and it's really intended to be a documentary camera. So it's running at 28 frames per second, not really a high-speed camera. So it's almost real-time, a real-time camera view. It's just a really beautiful shot, and because it's a documentary camera, we're able to enlarge the aperture so that the timing block isn't taking up image area, and present it in its widescreen view, and I think it's quite dramatic.
Yeah, from a beauty standpoint, this is probably at the top of my list for favorites. It's just gorgeous quality, fantastic color saturation, and very unusual for shuttle photography to be so beautiful at the same time.
So Echo 55 begins our series of tracking cameras. Echo 55 is mounted on a kineto tracking mount, or KTM, which we commonly refer to it as, and it's located at CS1 about 1,200 feet from the vehicle.
This is a nice shot because you can see there's a bit of a distortion cloud here that we're shooting through, and what that is hydrogen being burned off from the fueling system. They burn off any excess hydrogen to safely combust it, and so that's what we're seeing here, and it's really gorgeous as the vehicle sort of comes out of that and goes into its roll program, clearing the tower. Again, just a fantastically well lit photograph on this day. Some of the white things that you see falling off there are paper covers, which protect some of the order maneuvering system engines. We'll talk about those later. But Kevin, these are all manually operated, right? I mean, there are human beings behind the scenes doing this tracking now.
Yes, this KTM, or the kineto tracking mount, has about 4 cameras that are mounted on it, and this particular camera, Echo 55, is one of a pair of cameras, and is intended to look at the top half of the vehicle, while the other camera is intended to look at the bottom portion of the vehicle.
Right, and we'll see that in the next shot. We'll have one of the views from the bottom of the stack on the next one. In fact, our intent is to have in the deleted scenes on this disc a set of camera pair views sort of pieced together so you can see them simultaneously. So look for that in the extra features. This is a fantastic. Now they're completely done with their roll program and sort of on their way.
Yeah, the intent of that camera shot is only for the first 1,200 feet of the ascent. Is really the intention of that view, and that takes about 18 to 20 seconds, I believe.
Okay, now this is camera 52, and this is, of course, is at the bottom of the stack now, so it's a little different view, and but part of a camera pair again.
Right. This camera is, as you said, is 52, and this is located on camera site 2, and is about the same distance, 1,200 feet, 1,270 feet from the vehicle.
Nice shot of the SSMEs there. It always amazes me how transparent the exhaust coming out of the SSMEs is.
Now this kineto tracking mount is controlled by an operator, manually controlled by an operator who's sitting in the LCC on the second floor below the firing room. And the person, he or she, is using a trackball to track the vehicle. And it's pretty tricky because they're just looking at a little video monitor, and the vehicle is moving much faster in real time than we're seeing. We're seeing it at 1/5 the speed in this particular case of what it is in real time. This kineto tracking mount also has HD TV cameras that are mounted that are used for what we'll call quick look, what's called quick look, to look at these views in real time and then in near real time when they start the image analysis. This is done while the film is getting processed and transferred.
That was a fantastic shot, seeing the sun go right in between the two plumes. And in fact, it gives you an idea how bright these plumes are to the naked eye, because the sun, as it passed through there, wasn't much brighter than the plumes that you saw. Wonderful shot showing the column of fire that the vehicle rises on, and it really contrasts nicely with the blue. Again, highlighting why STS-124 was really the correct mission to sort of springboard off of, to show all the beautiful film.
This is camera 57. This is at CS6, again 1,200 feet from the pad or so, and we're looking at the bottom half of the vehicle. As I mentioned earlier, the camera is mounted on a tracker. A KTM tracker has 4 or 5 different cameras on there, and this is the lower half film camera looking at the bottom of the vehicle.
And you can see the paper covers come off the RCS engines. Those are Tyvek covers, just same kind of material that you put on your house when building it. And those covers are there in case they get a squall or a little storm while the shuttle's out on the pad. Not uncommon in Florida, and we can't afford to have water inside those engines, so we put those paper covers on there, and they have these little parafoils that inflate, sort of tear the cover off. They're just adhered with an adhesive of some kind. So you'll see a lot of that white paper coming off during these launch shots. Beautiful shot looking up the tail end of the stack. And possibly on the deleted features or the deleted scenes on this disc, we're going to try to edit a piece together showing the camera pair, the views from the camera pairs pieced together, and it should look pretty nice. So look at that on our deleted scenes feature on the disc.
This is Echo 225. As you can see, it's already in flight. It's a really interesting view. It's a medium range tracking camera. The mount and the camera are located at UCS4, which is about 2.4 miles north of the pad.
One of the reasons I selected this shot to be included on the DVD is because I thought it was really striking and really beautiful how in their roll program, as they went into their roll, the sun sort of peeks over like it does here, and you can see the name pop out, and slowly the whole orbiter becomes lit with the evening sun. And the textures are fantastic here. You can see the thermal blankets, you can see some of the thermal exposure to the thermal blankets, you see some variation in color, and you can see the tiles literally make out the boundaries of the tiles there. So really a wonderful piece of footage and a remarkable contribution to the DVD from a photography standpoint.
The lens that's on the camera is an 150-inch Bashir lens. It's a cat-eye dioptric lens, so it's got a mirror surface. And it's about 4,000 millimeters focal length if you converted the inches to millimeters. Just to give a perspective, Matt, the weight of this lens is about 250 pounds, just the lens itself. It's a huge lens and really unbelievable piece of optics.
You can really see a lot of nice textures on this shot too, on the booster. If you look at the forward part of the booster, you can see the access panels and that big line coming off of the external tank. That's actually the oxygen feed line on the external tank. That's where that 280 gallons a second of liquid oxygen are flowing through to the main engines. That feed line's about 17 inches in diameter, so it's a pretty beefy system.
And I think another thing to point out here is that this camera mount is manually tracked. So the operator is looking through a bore sight at the camera site, launch vibrations going on all around him or her, and keeping that vehicle dead center in the frame. And it's quite an amazing feat to be able to do that quite so accurately.
Yeah, they've done a great job of keeping on target every step of the way. Now they're getting a little further away, obviously, and you can see sort of the glow of those engines starting to come up against the bottom part of the stack there, as they call it, and lets you know that something's going on at the back end of that vehicle.
So the next series of shots we're going to see is the views from the HD cameras. And in this particular view, this is from STS-114, Return to Flight. So this was in July 26th of 2005. And we're about 2 miles from the pad, just south of pad 39B here. And the camera is cocked at a 45-degree angle to enable maximum use of the 16:9 aspect ratio that is available with the HD TV cameras.
Now it's important our viewers take a good look into the left window there. You can actually see Eileen Collins, who commanded this mission. You can see her suit inside the window. Absolutely amazing. And this is a first, right? This is a first in the program. We started using high-definition video after Columbia. And that was one of the first times we saw this level of detail in photography.
That is correct. So this particular camera view is EHV 225. This was recorded on STS 117. It was in June 2006. And the camera is running at 60 frames a second, as all the HD TV cameras do. The orientation of the camera is cocked at 45 degrees to make maximum use of the aspect ratio of the 16:9 frame to get as much of the vehicle, space shuttle vehicle, in the frame as possible.
This particular shot I chose because it's well exposed and it shows a beautiful sequence in the roll program, but you also get this really nice vapor phenomenon as the vehicle accelerates to higher speeds. And this is not always visible to the for every launch. It's a consequence of atmospheric conditions, dew point, humidity, etc. So I thought it was kind of a nice touch to this particular image. This is the only long-range camera that made the final cut, and Kevin will give you the details about that in a moment, but I want you to look at the bottom of the tank there. As you saw, it just sort of became engulfed in flames. And you should know that this is a normal phenomenon in a shuttle launch. What's effectively occurring here is the exhaust gases coming out of the SRBs and the SSMEs are sort of expanding into the higher vacuum as they head into space. And the radiant heat from the expanded plumes becomes high enough to ignite some volatile gases that are caught up in this aerodynamic dead zone, so to speak, at the rear of the tank for a couple of moments during flight. But this is an amazing shot, Kevin, because it's from so far away, so why don't you explain what we're looking at here?
Yeah, Matt, the camera here is located at a place called Apollo Beach. It's within Cape Canaveral National Seashore, and the camera mount is about 20 miles north of the pad, so it's quite a distance away. This is a Brashear 150-inch lens, again about 4,000 millimeters. So quite a distance, and the tracker, as we mentioned earlier, is manually operated. So there's an operator looking through a scope and using a trackball to
I like
keep
that. That was
the
pretty
vehicle
cool.
Field of view.
Just flow separation.
It's also difficult for the operator, because of the distance, to see the vehicle at launch to sight the pad.
Yeah, it's just
so
a tiny point of light, right?
So he or she grabs it on the fly, and it's quite a skill level that needs to be developed in order to do that.
Well, and of course we watched our solid rocket boosters separate, which is sort of at the tail end of what we can see with all of the tracking cameras. And there you see our boosters coming off, and they separated about 29 miles in altitude, about 2 minutes into flight, and they are recovered by divers out in the Atlantic Ocean. And although they appear to be falling back here, they're actually traveling another 15 miles or so up, just tumbling on their own forward momentum before they peak and then come back down in the Atlantic about 150 miles out.
All right. All right, all right. I'm just gonna say it. We should fly that. We should build more of those. Yeah, yeah. We should build more of those. Plume-induced flow separation is also the cause for the flames that walk up the side of the Saturn V shots. Yep, yep, yep. Thanks for that. Yeah, yeah. That's a good one, man. Ascent is amazing. That's such a good freaking. It's such a good such a good documentary. This one though, like, oh,
This view that you're
all right, just just back it up a little bit. Oh, no, okay, no, I like that orange rocket, Novus. That orang rocket is good. Orang rocket will do this. What I'm saying is we should have orang rocket and space shuttle. When are you gonna build the new and improved Collins? I don't know, man. Soon. Okay, but what if we build better versions of these instead of just more of them? Better versions? Better? Oh. Do you think STS SLS could have been developed into a flexible platform like Buran and Energia? Yeah, sure. Why not? Yeah, sure. Why wouldn't it? Why couldn't it? I know, Rock Guy. Unbelievable, right? Material science improvements. We could actually make lighter airframes that use BLE style SRBs to make. I mean, Vulcan. What do you think I mean when I say we should make more of those? Just make it to 1972 spec? No. Oh, of course, that's implied. That's implied. Yeah, Shuttle C. I think I don't know if an SLS in the space shuttle would be useful. I mean, they would be useful. I think the shuttle and Shuttle C would have been fine. Heck, the shuttle doesn't even need a metallic thermal protection system. Tough rock. The stuff that Starship uses on this thing would be a pretty damn good improvement. Tough rock would work just fine. The hexagonal tiles, I'm serious. The ones that they have on Starship, those would be great. That is a huge improvement because the Unifiber's reinforced oxidation resistant tiles mean that they don't absorb water as much. That was the problem with the tiles. They absorb water, and then water, I was about to say melts the glue, but that's not really the right word for that. Yeah, I mean, Vulcan, but yeah, that's heavily implied. So like a shuttle with some tough rock tiles and BOLE boosters, just to name a few things, would be fantastic. Yeah, that'd be really nice. Heck, a stir-welded isogrid ET would be way stronger than what they made.
Discovery, go at throttle up.
The inside of the external tank was not. That is what it ended up being. They did do an ISO grid in there. That's good to know. I forgot. The older insides of the tanks were. Yeah, actually, see, it's not an ISO grid. Yeah. See, it's not an ISO grid. They welded stringers to it. Lucifer, 22-month resub. Bada boom. Yep. ISO friction stir weld. So if they made external tanks like they made Vulcan or the SLS core, then yeah, it'd be really nice. That'd be really good. We could make some really, really nice improvements to this thing. Interesting, God, the SRB is turning Burning 10,000 pounds a second, 20,000 pounds total a second. That's equivalent to a fully gassed up A320 emptied in about 3 seconds flat. Yeah, that's the amount of energy you need to expend to move, to go up into space. Look at that thick aft section. These damn boys, she thick. Yeah. Yeah, we can make some pretty gnarly improvements to this thing. Actually, now that I'm really thinking about it, dudes, you know what would be the best combination of vehicles, like that of any shuttle-derived vehicle? If I had my choice, the 3 vehicles that I would operate are, well, actually, hang on, let me think about this for a second. Okay. I would want, okay, so stretch, we'll have like what would be the best 2 combination of shuttle-derived launch vehicles, and then we'll have the stretch goal, which is 3. If I had my choice, what I would have is, so a Block 1B SLS with RS-68s at the bottom instead of RS-25s. No crew would launch on that. It would be entirely for unmanned launches. RS-68s, 5-segment reusable boosters, EUS in the upper stage with a 8-meter fairing. That would be fine. Perfect. I would have that and the space shuttle. Yeah. That would be the game-changing combination. The shuttle and that. Stretch goal would be Ares 1, because it's not going to take that much more to build Ares 1 if you have SLS and the space shuttle. I mean, Ares 5. No, it could just be SLS with 4 RS-68s. I mean, but then again, Vulcan, SLS's core stage is Ares 5 for all intents and purposes. So are the boosters. It's just got shuttle engines down there instead of RS-68s. Yeah, I would remove the man rating requirements off of SLS, because screw that. Why would you do? Yeah, I don't know why you'd do that if you had the shuttle, right? So yeah, shuttle, and basically Ares 5, but not Ares 5. Ares 4. We'll say Ares 4. Call it a day. Yeah, it's pretty much Ares 5. Yeah. RS-68s aren't as efficient as the RS-25s. That's why Ares 5 was 10 meters wide. I mean, if we wanted to have one assembly line that's making SSMEs and RS-25Es, then we could do that too. That'd probably be better. What do you think would be cheaper? Building a lot of a more complicated engine, or building less of a more complicated engine and then building more simple engines? You know what? I'd standardize the line. Standardize the line. RS-25s. Yeah, that's a good idea. Yeah, just basically SLS Block 1B cargo. That would be good. And then you could human rate it if you wanted to. But see, yeah, and then from there you could build Ares 1. It's basically all of how about, wait a minute. Would that work? SLS is just Ares 5. It is. You've said that. You said the core state. You're the one that told me that, you dope. Don't people leave. Get over here. Hmm. Well, Vulcan, I was just thinking, just put an EUS on top of a 5-segment. I mean, I think that might end up like Starliner Not 22. It's going to produce some very strange aerodynamics, that's for sure. You're getting it all wrong. Jupiter Direct with the EUS for manned cargo. Nah. I want this. I want this back. Can we get this back, please? I want that. So it's not Ares 5. The core stage is brand spanking new. Very little of Ares 5 made it into the core stage. Yeah. Okay, fine. What would you call an SLS with RS68s added and no crew rating? So Block 1B with RS68As instead. What would that be? No. I mean, if we're picking and choosing, screw Direct. Direct was a Band-Aid fix. Screw that thing. No, I don't want that. I want the shuttle. Give me the shuttle and SLS. That would be fine. I'll take shuttle and SLS. That's okay. Yeah, that'll work. Standardize this and move the engines to the bottom of the orange tank. Nah, throwing away too many shuttle engines at that point. You ever stared at it? Marveled at its beauty? Its genius? Oh. I want it back, guys. I miss it. I miss that thing. I miss that thing so much. I want it back. I've decided. You know what? I'm just gonna say that from now on. We should make another space shuttle. Make another space shuttle. It's pretty good. It would be really good. I mean, but then again, Starship is basically Shuttle 2.0 for the most part. It's good enough. That'll do. Anyway, welcome to Space News. Here, let me start compiling some links here. That link, the Sierra Hab link, we already went over. I don't know that guy, so I'm not going to share that picture. Don't know that. Rifling through the links here. Zach is just the same thing. CNBC continues to be paywalled. Hilarious. Oh, no ad block. Okay, that's Starship stuff. Satisfactory Update 6 should be coming soon. Let's go there. Already have that. Got that as well. Sweet. All right. Also, they were considering adding a 6th RS-68 to Ares 5 towards the end of the program. Ares 5 was still well into development. Yeah. What do you think of an SLS core stage wet workshop? I think they should do that. Aqualex, like, okay. Wet workshops could work. I was much more of a proponent of the external tank wet workshop. I think that would be a better idea. I mean, Novus, a 6th RS-68 would be insane, dude. That would be ridiculous. What's that, AFD? It's not loading for me. Yeah, it's not loading. Sorry, man. Yeah, I would go with Shuttle and SLS. That would be good. Shuttle SLS, and then ideally Ares 1 would be good as well. But then again, you could just carry the Orion capsule inside of the shuttle's payload bay, and you'd be fine. It's been doing that, Hellfish. What do you want me to do about this? Thread on the link that wasn't loading. NASA contractor Chinega Infinity are moving forward with the plans to close one of 3 fire stations at KSC. The one closest to Artemis Pad 39B, station number 3, will be shut down by the end of this month. Reasons, according to KSC, include Station 3 was involved in 10% of all calls at KSC at an average cost of $65,000 per response. Station number 3 has not responded to any fire calls in the past 5 years. Because of the proximity to pads 39A and 39B, it has to be evacuated during launches and cannot respond. Didn't they have to jettison the engines to do a first stage wet workshop? No. I think that's, well, I mean, Creeper, that was part of the reason why I said doing that with the external tanks would be better. Aft cargo carrier, airlock on the back of the hydrogen tank with pressurization and purging for inside. So basically, when the tank's up in space, the shuttle separates from it. There's an aft cargo fairing that deploys. That deploys actually before the shuttle separates. It just kind of slides off, and then the shuttle boosts up into space. Once it's up to the right orbit, the shuttle separates, docks to the bottom of the tank like this, and then inside of the aft cargo carrier, you have enough to repressurize the hydrogen tank. You're gonna have to make a stopper for the plumbing, though. I'm not sure how they do that. But yeah, well, I mean, provided you could do that, that would work. It'd be pretty good. With the aft cargo carrier, just repress the tank, purge it out with nitrogen, and then mix some O2 in there, and then you got perfect nitrox inside of there. I say that like that's some easy thing to do, but that actually is not as crazy as it sounds. It's not really that big of a deal. The aft cargo carrier will do it, Aqualux. Here. Shuttle. Aft cargo carrier. You don't even need to move stuff inside of the payload bay. Look. I mean, this idea was basically proposed by NASA, but look, here, take a look. Hey, it's just a payload. It's just a backwards payload fairing on the back of the external tank. That plume-induced flow separation area, that big place. You could put stuff there. It's really not that big of a deal. Because you got to remember, that will actually stabilize this out. You're more in line with the stack. And the gimbals on the shuttle engines could compensate for that slight shift in mass. It's really not a big deal. So basically, you put a space station module on the back of this that's attached to the external tank. And then the shuttle would have to have no payload bay, but basically a docking ring on the very bottom of this. Right? And then you have tanks around it that'll repress the hydrogen tank. And then you use the LOX tank as a waste tank. Oh, you mean internal furnishings? Yeah, you'd need a CBM to do that, but yeah. Yeah, so this would have to be a multi-axis node so the shuttle could bring up the MPLM and attach it to it. But yeah, NASA had an idea. They wanted to do stuff like this. They wanted to do stuff like that, actually. Basically daisy chain a bunch of tanks together and make a fuel depot in space for deep space missions. It is a really, really freaking good idea, actually. What would you purge the LH2 tank with? Nitrogen. Nitrogen. Carry some nitrogen tanks back here. Put all the life support systems back here. Big reservoir of nitrogen, and then a little reservoir of oxygen. Get 7921 and go. And then you have attached to the bottom of the external tank, which there's already a bulkhead right there. There's already a bolted bulkhead on the back of the external tank. They used it for manufacturing. There's already a hatch there. You can literally see the hatches right in the shot. See them right there? They're already there. It's already see that's what those two things are on the back of the ET. Take a look. That's what I mean. That's so easy to do. Just start chipping off the foam. No. Just have a thermally insulated hatch. Just CBM back there would do it. And you could just chip the foam off, I guess. Like I wouldn't put any foam on. Oh boy, you're gonna take a little. There's gonna be some ice on the back of the external tank. Oh no. Or you could just put another inner tank back there and use that as the structural bulkhead. It would work. Like this is not, like I said, NASA proposed this idea. They wanted to do that. That would have been a really good way to move pretty big cargo up into space. You guys don't understand. That's an 8.4 meter payload fairing. It's huge. put a lander in there. If you really wanted to. Can't fit it inside of the shuttle, you put a lander in there. A lot of space. There's a lot of space in the trunk there. Just saying. You put a lander there. Capsule up there. Dump the capsule out. Dump the external tank. Capsule attaches to the lander. Plucks it. Goes somewhere else. Or the shuttle brings up some fuel. Or you bring up a wet workshop ET and you use it as an upper stage or something. There's a bunch of things that you could have done with this. That's what annoys me about the shuttle the most. They had all that capability and you didn't do anything with it. Anyway. Speaking of capability, not going down the tubes, here, check this out. This is coming from Mike Sheets over at CNBC. Rocket Guy, if you're here, this is probably good news for you. Lunar company Astrobotic confirms the acquisition of the bankrupt Maston Space Systems, saying operations will continue at the latter's facility in Mojave, as well as development of the Zogdor rocket. Oh, Zogdor is intact, thank God. What's Zogdor? It's a vertical takeoff, vertical landing demonstrator. Hey, Winterscythe, what's going on? Yeah, Zogdor. Zogdor! Yeah. Here. That's a concept of Zogdor. This is completely a joke. The day you talk about the shuttle without talking about the bottom of the tank will be the day pigs fly. It's a good idea. It should have been done. It's really stupid that it's not. Anyway, that's good news. So here's the press release. Let's see. Astrobotic announces today the acquisition of Maston Space Systems, a pioneering space technology company with industry-unique suborbital payload testing services, which include the heritage of more than 600 vertical takeoff and vertical landing rocket flights. The acquisition also includes Maston's portfolio of advanced space technology development programs and over 18 years of operations. Astrobotic and Maston's combined workforce of more than 200 employees will continue operations in Pittsburgh and Mojave. The combined company will maintain suborbital flight operations at Maston's test sites at Mojave, with plans to continue offering the space industry a key testing site for hot fire rocket tests. Maston's suborbital launch vehicles and propulsion test centers are national assets for the space industry. We are excited to operate and expand these services for companies, governments, and space agencies internationally. Bringing these services to Astrobotic is a natural fit for our mission to make space accessible to the world. Maston helped establish itself as a leader in vertical takeoff, vertical landing innovation in 2009 when it won first prize in the Northrop Grumman Lunar Lander X Challenge. The win helped lay the foundations for Maston's one-of-a-kind vertical takeoff, vertical landing flight program, which has demonstrated industry-leading landing precision and rapid reusability over its 600-plus vertical flights to date. Since 2011, Maston has served NASA's Flight Opportunities Program to provide flights to NASA-sponsored payloads to prepare them for spaceflight. Maston rockets have flown payloads for current and future lunar and interplanetary missions, including Astrobotic's OPAL Terrain Relative Navigation System, Honeybee Robotics' PlanetVac system, and NASA JPL's Lander Vision System for the Mars Curiosity mission. At Astrobotic, the former Maston team will continue to offer and develop its unique test capabilities, including providing vertical takeoff, vertical landing test flights for commercial and government customers. Astrobotic plans to expand these test flight offerings with the development of a next-generation Zogdor rocket, which will offer higher altitudes, longer missions, and supersonic flight for suborbital payload testing. No, it's not sad at all, Rocket Guy. Astrobotic literally just saved Maston, and if anything, they're expanding their operations. Yeah, that's what this article is, dude. Look. Astrobotic literally, they bought Maston, and they're expanding it. They're keeping everybody hired, from what I could understand from that article, and expanding their capability in Mojave. That's really, 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 really good news. That's really good news. Good. Yes, make more rockets, you dopes. Still sad that this is happening in the first place. Yeah. 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 Yeah, but hey, Astrobotics saved the day. I wonder if they're going to keep the Mastit name. I would. Brand recognition. Key. That's really cool. Astrobotics seems like good bunch of guys and girls. Builds rocket. Here's your rocket. Good. I'll take it. Mastinobotics. Only makes sense to do that if Dave stays. Mastin, an astrobotic company. Yeah. I know who you meant, Rocket Guy. But anyway, not the worst news in the world. So check this out. Little interesting tidbit of information from SpaceX. Starlink is now on all 7 continents, in such a remote location like Antarctica. This capability is enabled by Starlink's Space Laser Network. National Science Foundation supported USAP scientists in Antarctica are over the moon. Starlink is testing polar service with a newly deployed user terminal at McMurdo Station, increasing bandwidth and connectivity for science and support. Wow. Wow. Yeah, there it is. Cool. Well, that's pretty neat. Boca weather update. It's raining sideways. Okay. Everything else here is basically just Starship news. But here, let's go over to rocketlaunch.live. Let's see what we got. We do have a Falcon 9 a little bit later tonight. 9:48 p.m. This is a 24-hour scrub from yesterday. So, yesterday they didn't go. There was too much lightning, even for Falcon 9, so they didn't send it. But Starlink 61 out of Slick 40 should be launching soon. Now, this is an article here from Mike Sheets. Let's see. This is Mike Sheets is the science reporter for CNBC. Let's see what he's up to. Northrop Grumman executive says SpaceX's Starship rocket has awesome potential, but it's not there yet. Radar definitely not looking great for that launch. Weather isn't looking great at the moment here in Daytona. What's it look like at the Cape? I'm going to assume not good. Rob Haig, president of Northrop Grumman Space Logistics, on Wednesday said that Starship is going to be an awesome capability. Still, we need to see a mature launch vehicle. Starship's not there yet. Northrop Grumman has an agreement with SpaceX to launch robotic spacecraft that extend the life of satellites on orbit. Oh yeah, the IAC is going on right now, guys. The International Astronautical Congress, IAC. It's basically E3 but for spaceflight stuff. The leader of a Northrop Grumman subsidiary that's working with SpaceX sees exciting potential in the private space venture's massive Starship rockets, but warned the industry should temper expectations until it hits key milestones. There's still a lot of work to do. We need to see a mature launch vehicle. Yeah, Haig's working on MEV. That guy's from it. He works on the MEV program, Mission Extension Vehicle. Huh. Pizza. Okay, there ain't much pickings there. And that's honestly not really anything we didn't know. Starship's still a good ways out, guys. It's not. What does he mean by a mature design? So, a 747 is a very mature design. The 747 basically matured with the 747-100, and it's just been upgrades from there. 50 years ago, might I add. long story short, saying it's not matured yet, we got to temper our expectations, basically means it's not ready. It's not ready to go into operations yet. That's not anything we didn't know. Every aerospace project needs some time to develop. Look at Falcon 9. Look at how many times Falcon 9 got it wrong before they nail every landing. Now if it doesn't land, it's a story. 5 years ago, if it landed, that was a big deal. You know what I mean? That shows Falcon 9 maturing as a design over time. Pretty straightforward stuff. Is it just me, or does the MEV seem suspiciously like a commercial application of a military concept? I don't know what you're talking about. I mean, of course it's not a mature design. SpaceX hasn't even achieved a feature lock yet. Pretty much. I don't know what you mean. So, okay, this comes from a person we don't really know at all. A guy named Aaron Jones took a tour around KSC, and he did take some pictures of Starship's pad. He got some pictures of Starship's pad at 39 here. This is at 39A. There's the booster hood. That is a big booster hood. And looks like they're getting ready to move the 9th segment. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, they're getting ready to move the 9th segment here. Also, SLS is in the background over there. Yep. So yeah, these are pictures from Aaron Jones there. Yeah, pictures off the bus. Cool. Man, thing is coming together a little bit fast. Legs are almost ready for the plate. Yeah, they look it, dude. And just goalie, just as I suspected, these legs aren't going to go up and go straight like the padded Boca. It's just curved all the way up to the top, isn't it? They don't go up and then turn. They're not going in and up like that. That's just straight to the top. Straight to the top. Cool. Hope this one will be completely level, unlike the one at Boca. Okay. Yeah. Bird. Yeah, it's because the design didn't change partway through. Because they changed it because the design didn't change, Creeper? Redundant statement. Department of Redundancy Department statements. Wait, have they even used the first launch pad yet? Only for static fires, Semi. Yeah, crazy, right? That tells me that they must have locked in on a design. The pad is at least baseline to an extent. And if the pad's baseline to an extent, that means the booster is too. So now it's just really a matter of qual testing, right? And that's basically what we've been seeing with all the static fires. SMH my head. SMH my head face. Okay. So let's watch the Starship video for the day. Let's see what we got. Video's coming from Nick and Sweeney here and Starbase Live. It'll be interesting to see what changes after our first flight and by how much. Potential downfall of spiral development. Yeah. Oh, ship 25 stacking. Are you real? I need more coffee. What is real? How can you define real? If real refers to what you can see, smell, or touch, then real is just electrical impulses being interpreted by your brain. I'm trying to find the real. Okay. Okay, you do that. So that's the Starship Can Crusher, or if you want to talk about it in rocket terms, it's a dynamic test stand. Does the transporter have enough wheels? No, it needs to have at least 3 times as many. Oh, there's the extra wheels, Kentem, just in case. Look at that thing. Is that strange? At any other place, that might seem strange. Job 6 lifted ahead of Booster 7 testing. This is so they don't get damaged in the event of an anomaly. We need to secure the area? Spin it to win it. Oh yeah. 33 engine spin prime test followed by a nitrogen purge. There's the nitrogen. Interesting thing coming from Alejandro. What's that? This is from Alex. Yeah, Rocket Guy, it looks like they hit the thing with nitrogen after. In fact, it looks like a nitrogen purge right after. So that's propellant. And then that's nitrogen. See that? That second puff? And it's the gas is slightly grayer. Yeah, that's nitrogen. What is a spin prime? Cooking. You ever start a car and the engine doesn't turn on? That's basically what they're doing. They're just cranking it over. The rocket equivalent of it, though. Alright, what's this? Apart from 39A and LC-49, the only other place SpaceX is thinking of putting a launch and landing tower is at Slick 47, but that place is tiny and needs more development. So far, no place other than 39A is showing any signs of getting a tower of any kind. Not LZ-1, LZ-2, not Slick 40. Work hasn't even begun on LC-49. Any work on a third tower and its location will be seen for miles. Literally, Harriet will get satellite pictures of it and will know even before anything can go fly and take pictures of it. Like 47? They're bound to want to put one on the West Coast somewhere, right? I don't know. "17 is open." Oh, wait, no, that's Moon Express or whatever. Yeah, the Starship pad that they're building, guys, is basically right here. It's right there. Hmm. Elon hands you a map and says, pick where the next Starship pad goes. Where would you put it? Right there. Yeah, right there. Yeah, pretty much right there. Just mirror it. Mirror what they're doing right there. Just put it over there. And then Aqualex, here's what I do. When Starship starts flying and Falcon 9 gets phased out, right? So this is in like 15 years or something. I would build a third pad right there. But here's what I would do. I'd build a third pad there, but I would also have a Starship maintenance facility inside of the VAB high bay. Get rid of Falcon 9's pad, get rid of the HIF, reactivate the crawlerway, buy a crawler transporter, and I would have a Starship processing facility right here for loading payloads. Could be here, could be high bay 2, could be high bay 4, doesn't matter. And then you could move Starships out here, right? You could move them back this way, like an HLS or a depot Starship or whatever. You know, you have a payload processing area over there. You have a big building. You could literally have the whole vehicle inside. And then what I would do is I would three-way split the crawlerway. One of the crawlerway things would go right to the first pad. The other crawlerway would go right to the second pad. And then that crawlerway would go to the third pad. That way, on the north side of the pad, you could have all your commodities, and those could be completely separate from all the other pads. So when boosters are coming back down into land, they don't need to worry about landing anywhere near the tanks. You know what I mean? And then I would have 3 pads. Or the other thing that you could do is just not use 39A as a pad at all. Just put your Starship processing right here, and then just move the Starships back and forth. But that's what I would do. I have a crawler when you have SPMTs. Crawlers could move they could move super heavies into the VAB for storage. Yeah, if they're not using them. You think they're going to put one at Vandenberg? A Starship launch site from Slick 6, Tessa, would be... It would be... Yeah, you could do that. Sure, why not? I mean, yeah, there's no real reason to put one at Vandenberg. You could launch Polar out of the Cape with Starship. That really wouldn't be a big deal. Yeah, guys, SpaceX could, yeah. If ULA gives up the pad after Delta, the last Delta 4 is there already. It's already on the pad, if I'm recalling correctly. But yeah, you could launch Starships from here. Sure, why not? I don't see why you couldn't. I know what people are going to say. How are they going to get there? The heavy infrastructure is already there. The heavy infrastructure is already there. It was designed for shuttle external tanks, which are pretty much as big as Starship. You'd have to figure out a way to move them on their side, though. But then again, SpaceX uses this dock more often than not nowadays to move Falcon 9s that have come back from the Cape. True story. Just build another factory there? Well, you got the real estate. There's plenty of space, Phil. Yeah. Yeah, I mean, there's enough former shuttle facilities here to be able to build a ton of stuff, actually. And that really cool looking kidney bean shaped parking lot. I'm not sure if those flame trenches would be able to handle 72 meganewtons of thrust, though. You'd need to open up the shuttle flame trench. There's a elbow-shaped flame trench right here that was designed for the shuttle engines. Because at Slick 6, you couldn't have the shuttle engine go this way. It would go into the building. So they diverted the flame 90 degrees. So right SRB, left SRB, 3 main engines. The shuttle facilities are all being used at the moment, not by ULA. Yeah. Yeah. I know. Look, okay, all right, fellas. I'm just gonna recap that conversation. The whole theoretical question of this was, where would I put another starship pad if Elon asked me? For what it's worth, I didn't even say Vandenberg. Chat suggested Vandenberg. Chat answered the question for me, and then I went, and then I was talking through whether that's, whether you could do that or not. I know that's like 6 facilities are being used by something else. I get it. I get it. By someone else. I know who's using them. But I don't know what you're talking about. I don't know what you're talking about. But remember, this is all a theoretical question. The whole thing was theoretical. There's 2 pads. There's one in Boca, there's one in the Cape. That's good enough. And then then on top of that, there's the 2 oil rigs. We don't know what those are doing. But remember to understand the context before you weigh in on things. That's really important. It's a really important thing to understand. Jackal, thanks for the 5 subs. I do appreciate it. Anyway, let's get back to the Starbase footage. Here's more spin prime tests. Yeah, Hokey, sure. Ooh, ship 25 mating. That's a telehandler. It's not a telehandler. That's what are those man baskets or something? You guys want that job right there? It's a long way up. Hey, Grab Shark, what's up, man? Yes, I do. I applied for that job. Oh. Okay, touche. Great fog after a migraine all morning, so I'm having an excellent Wednesday. Yeah, I hear you. Man, Star Factory went up real quick. They already got the lights on in there. And I saw the tweet, but yeah, look, there's already barrel segments in there. See them? See them in the background? Jeez, that's fast. That is a tracking antenna. I'm not sure, Katra. Yeah, Johnny, I've been doing that for years. I agree with you. That's pretty cool. Hey, wait a minute. Wait a minute, fellas. Okay, EJ has a question here. What is this? What is this thing? Is that the table thingy? Is that a service gantry for the It's a Raptor work platform. Yeah, it bolts. It bolts to the bottom of the pad. I didn't know that. I thought they just lifted it up on a forklift and it kind of stays there. It's on motors? Several pulleys lift it up. Yeah, no, I've seen Work Platform 2.0, fellas. It looks like a folding table, right? Like the table with the sides that you can fold up, right? Like I get it. I didn't know it could just sit there. I thought they'd have to like lift it up into place and keep it there. No, it just go up there. It has chain winches around the pad and they mount it with pins. Cool. That's really neat. Well, that's pretty neat. Guy's loading nitrogen. The stand is removed from under the folding platform. Yeah, super cool. Yeah, that's the question that I was gonna ask. Why is it bolted to the crane? Yeah, there you go, Roadrunners. I'm with you. You can make a ton of Dippin' Dots with that nitrogen. It is the ice cream of the future. Yeah. Oh, those guys are inside of it. Oh, that's so cool. Nah, there's about 20 missing Kuro after the static fire. Perhaps the crane is giving structural support while maintenance hatches are open and the vehicle is depressed. It's possible, but I'm pretty sure Starship can freestand on its own, Darius. But yeah, I'm sure that crane is definitely doing what you're saying. Yeah, absolutely. Boat. That's my boat. All aboard the Steiner ship! Maybe there's a safety backup. Yeah, they've never done that before, though. Boat. Hey, guys, they've had people like going up inside the thing before with no crane attached to it. That's what I'm trying to tell you. My boat. All aboard the Steiner ship. Boat. They did do it before the 6-engine static fire. Interesting. Don't ever recall that in recent memory, but still, very cool. All right. Excellent. All right. Maybe they've had more scrutiny since the big burp. Yeah, maybe.
And in today's video...
Okay, there we go. This is the next bit here. So this isn't necessarily space news. This is more gaming news than anything. So Coffee Stain announced this. These are the people that make Satisfactory. They're announcing that they have a new update. Update 6 for Satisfactory is coming very soon. So here, let's watch the video real quick, and we'll go from there.
We've never done before. We're going to reveal the next iteration of the game, Update 6, in its entirety. But also talk about how, starting with Update 6, things are going to be a bit different. Ooh, mysterious. Just to put my cards on the table here, this video is going to be mostly an informative video about the update and what we're working on. You won't necessarily see too much of anything new today because we still want to treat you to all the new things we've created in the form of teaser videos, devlogs, or videos where we talk about these topics.
I think we may have seen this one before.
We want to reveal the core topics of this update up front because we sort of want to set the stage for how we intend to work on the game going forward. I'm sure you're very curious.
Yeah, we did. We did see the update 6 stuff. Yeah. Okay. Cool. Yeah. All right. We've actually seen that stuff from Snoop before. I don't know why. I don't know why the blog post came up again today, but hey, whatever. Yeah, the rolling update. What's that for? So nix that news. Stoke space. Oh, this thing. Yeah. Actually, we'll get back more into space news. Yeah, I was wondering, like, guys, sometimes like I play so many different games, I can't really keep track. It's hard to keep track of what updates and what hasn't. I saw update 6 and I'm like, maybe it moves off the beta branch and goes to full release. It's probably what somebody was trying to tell me earlier, but what is in it? That's when they redid the North Coast of the biome. I can show you guys. We'll play more Satisfactory in the future. But here, this is Stoke. I haven't showed this on stream before, but this is a very interesting thing, and I have no idea how it works. Yeah, maybe we'll learn something here. 70% probability of violation for Starlink per the L1. Not looking good. There's another newer bit on update 6. Oh, okay, character. That's good. Is this supposed to be an arrow spike or? Hello, Gun. We're 18 months out of seed funding, and it's time for an update on our rocket progress. Thrust chambers designed and tested. Oxidizer turbo pump designed and tested. Fuel turbo pump designed and tested. One hydrolox facility designed and built. Well, if it is, it's an ugly one. It's designed to serve a purpose, not to be an aerospike. We've been heads down on hardware and our communications are behind. Give us a minute and we'll get you caught up. Stay tuned. Yeah, I'm going to need Rocket Guy to help me out on this one. I see what it's doing. You have a power pack, and that power pack is going into a distribution manifold, and that's going out to a bunch of small engines around the outside. It's important to note that not all of the engines are mounted. There are some empty holes there. Yeah, that... Remember this. Vaguely, Core. Oh, yeah. I remember now. Yeah, Mile. Yeah.
Space launch is missing all of the key factors that make commercial air travel affordable and on demand. Commercial customers are looking for low cost, they're looking for schedule flexibility, and they're looking to get to orbit as fast as possible. Traditional approaches don't meet those three needs.
We think we're really well positioned to serve that market and fill the gap in supply that exists today and is only getting exponentially larger tomorrow.
Stoke is building 100% reusable rockets designed to operate at an ultra-high flight cadence. That is our singular focus.
We have, as a community, demonstrated that rockets can be reused at something like a prototype level. The next step is to turn it into something that's operationally reusable.
Achieving full operational reusability together with high cadence launch
I remember this
is
thing.
essential to creating order of magnitude cost
these guys are
reductions,
trying to make something
as
like
well as unlocking
SERV.
a paradigm shift towards seamless access to space.
The ability to quickly iterate is the most important part of the engineering process.
By bringing manufacturing and rocket engine testing in-house, we're able to design fast, build fast, and test fast.
A small team of highly capable people is a much more capitally efficient and much more time efficient way to get from nothing to viable product, and that's our approach. When you can deliver a service at 20 times lower cost than what's available today, it also opens entirely new markets.
Yeah,
that
I
even
remember
we in
this
the
now,
industry are
Tor.
not thinking about.
You can think about it like the Eisenhower Interstate System or the Apple App Store. We're creating the foundation upon which people can innovate and build new things.
The inevitable future is where you're not throwing away rockets after every launch.
We want to build the rocket that flies every day to every orbital destination and serves an unthinkable number of customers.
Come ride with us as we create routine travel to and from orbit in a seamlessly connected Earth and space.
Yeah, these guys are basically... So, okay. They're trying to make a fully reusable second stage. And how they're thinking about making a fully reusable second stage is by basically making your second stage pod-shaped. That's not the worst idea. Not the worst idea in the world. There have been ideas like this in the past. Now, what I'm about to show you isn't exactly this a similar thing. Isn't exactly the same idea, but it's not a bad idea either. So check this out. This is Chrysler's SERV. SERV is basically, it's an SSTO, a Hydrolox SSTO, that is pod-shaped. And how does it come back down? Well, the bottom uses a metallic heat shield piece. But on the way up, you have a ring of rocket engines, right? And there's little flaps that open up in front of the rocket engines. So on the way up, the flaps are nice and open, and it gives you a nice stable lift. They act like fins on the bottom of a vehicle, right? And then once you're on orbit, you deploy your payload. Inside is about a shuttle payload bay sized payload. Pretty good. And then the flaps fold up, and that whole bottom becomes the heat shield. It covers the rocket engines. It protects the rocket engines, right? Through re-entry. And then the crazy part. The crazy part is that it has jet engines. And it's a VTOL. Jet engine landing. Hayes Grayart did an animation of this thing, which is just absolutely amazing here. Yeah. It's not the worst idea, and yes, it's Chrysler, the company that makes cars. This is what they wanted to do. It's not as far-fetched as you might think. So this is not necessarily an aerospike engine. It's not an aerospike engine. It's kind of the same idea, but not exactly. You do get somewhat of an aerospike phenomenon from doing something like this, from putting engines in a ring. Falcon 9, you could see it with Falcon 9 when it's going up into space. It has a kind of an aerospike-ish type flame that looks exactly like that. That does give you benefits because you can accelerate the gases faster when there's low pressure on one side. Well, not necessarily low pressure, but that's the idea. You're getting some benefits, but it's not an aerospike engine, guys. It's not what we would call an aerospike. It's kind of an aerospike, but it's not. So that's what SCRV was supposed to do, and then it'd come back down, right? It's an SSTO, so it's going to come back down, and it's just a stage that's shaped like a pod. And then you would have had flaps that open up at the bottom. I don't know why you'd land two at the same time, but yeah, loud. Why was it canceled? SCRV never made it off the drawing board. Yeah, that was loud. Sorry about that. SCRV never made it off the drawing board. Believe it or not, that's what Chrysler proposed for the space shuttle. Yeah, that was Chrysler's proposal for the space shuttle. Sorry, what was that? Yeah, I get it. It was loud. My ears got blown out too, fellas. Yeah, that design lost to the space shuttle. Stoke is trying to do something very similar to SCRV, but it's a second stage that does that. That's what that ring is. I remember now. We went over this, but it was very brief. SCRV is better than shuttle? Venture Star, I think, is the best way to do that. Would that have even worked? Jim, yeah, I don't see why not. I mean, it'd work. Get anything to work. Question is, would it have been cost effective? That SCRV would have been pretty freaking expensive. I don't know, considering that the heat shield for SCRV was never really thought about. It's just the heat shield on SCRV is just made out of hopes and dreams. I don't know what the hell you would use for a heat shield. Maybe a metallic, like I said, a metallic one. Metallics could work, but that's heavy. Would it have been reliable? I think it was using J2's Hellfish, so yeah, I don't see why not. Why does it seem like Venture Star is always the answer? That is literally the simplest way to make an SSTO file. That's the reason. If anybody has a better suggestion for making an SSTO, I'm all ears. I think Venture Star is the easiest way to do it. And Venture Star is absurdly complicated. Like, absurdly complicated. Yeah, Skylon would probably be cheaper. I'm thinking about in context of like a rocket that goes up and like a vertical takeoff rocket. A horizontal takeoff and landing. Yeah, that probably is the best one. Venture Star is behind that, but yeah, it's still one of the best ways to do it. But you got to remember, Skylon runs off hopes and dreams. Venture Star's motors actually work. Yeah, you gotta remember that. Supersonic retro propulsion. High ballistic coefficient. Yeah, it's possible. It's still heavy, man. It's got like, what does it have? Like 15 engines in it? SCRV? I mean, I suppose you could do supersonic retro propulsion with that, but that means you got to open the flaps. You're going to open up the flaps during re-entry? Yeah, see, Skylon, I've never seen a Sabre engine work. I've never seen a Sabre engine work. Yet this also exists. Can't believe they got propulsion working. Cancel it. What a joke. aerospike, man. Hydrolox linear aerospike. That's a damn shame. I don't know, Hellfish. I'd have to go look it up. Yeah, see, that's what I mean about VentureStar. VentureStar's engines already exist. Just a damn shame. And then in Tim's aerospike video, it's actually there. If we just go in here a little ways. There it is. Funny story, that's actually part of it. That's not all of it. But yeah, there it is behind Timmy there. It's just a J2. It's a J2 with the power pack feeding a bunch of smaller rocket engines. Exactly like Stoke. Yeah, same idea. Anyway, yeah. Interesting thing from Stoke. This is actually a lot cooler when you look at it like this now.
Discovery, go at throttle up.
What's to stop them from making an air-breathing aerospike? Thermodynamics is the end of that sentence, Tessa. Thermodynamics. When you're flowing liquid oxygen into a rocket engine, the oxidizer stays nice and cool. The problem with an air-breathing rocket engine like that is that A, you have to intake an insane amount of air. And B, your air coming in is extremely freaking hot. From Wikipedia, thrust sea level 1900. Hellfish, can you believe that? 1900 kilonewtons of thrust. A J2 produces 1,000, and that's using that has a J2 power pack on it with different engines and a different nozzle. Can you believe that? That engine was money, dude. Oh, it was money. Chill the air with the H2 line before feeding. How? You need, then that's, see, that, Tessa, that, before, okay, so I'll just talk you through it. Yes, you could do that. Hydrogen, yeah, you could probably get away with it. But also at the same time, your hydrogen now turns to gas. Now what do you do with it? You can't spray it into the rocket engine. Now you have gas, so you need a way for it to atomize, and then you need to deliver more liquid oxygen to light it, right? If you use a hydrogen to exchange the heat, you're getting gas going into the engine, which means you're going to be you're basically running a staged combustion cycle, air-breathing engine. Now you have to deliver more oxygen because you atomized you evaporated your fuel essentially with the heat exchanger. So now you don't have enough root fuel, and now your motor leans out. That's the problem that Skylon is trying to solve. Skylon is using the extremely cold temperatures of hydrogen, but they're using a helium pre-cooler in a closed loop system that exchanges heat with the propellants. That's how they're doing that. Yeah. The rocket engine has a helium loop in it, and the helium loop is why you never hear anything about Skylon, because that is extremely difficult to do. Helium doesn't like being a liquid. Yeah, it doesn't like being a liquid at all. But the shuttle used the fuel to chill the nozzle of the engines. I just explained that. Yeah, like just a second ago. That wasn't chat delay or anything, right? 455 ISP and vacuum. Yeah, Hellfish, that's a gas generator hydrolox engine. Can you imagine a full flow stage combustion cycle aerospike? Unbelievable. Or a fuel rich stage combustion cycle aerospike? Yeah. Specific impulse will go up above 460 all day. That's what I mean. Venture Star, man. Skylon is doable, but you have to invent technology that doesn't exist yet or is being worked on right now. Venture Star could be made with modern technology, and the engines were invented 20 years ago. And we could upgrade them from there. Aerospike with a Raptor 2 power pack. Yeah, that would work. Yeah, Tessa, I know this shuttle used the fuel to chill the nozzles. I get it, but remember, they can always just spray more liquid oxygen. That's what I mean. You have liquid fuel, and you have gaseous oxidizer. So now it's working. That's what you want to do to make a jet engine, right? To make it air breathing. If you're exchanging the heat in this particular scenario, you got to find a way to cool the oxidizer down. Now, you could do it with just the hydrogen. Sure, why not? But once again, it's better to use the helium pre-cooler, the helium loop. That's what Sabre is doing. That's what the Sabre engine is doing, the Skylon's motor. But once again, that's technology that doesn't exist yet. The RS-2200, that footage, you saw that footage. The footage of the RS-2200 that I just showed you guys was in 4:3 aspect ratio, meaning it predates high def. Yeah. Can you please explain specific impulse? Miles per gallon of the rocket engine. It's the efficiency of the motor, Flykin. Specific impulse is derived from the total impulse of the engine. So basically, how much energy can the engine put out? How much energy can it put out in the form of, heat and gases accelerating out the back? Yeah. It's derived from total impulse. Basically, it's the miles per gallon. Miles per gallon. The higher the specific impulse number, the more efficient it is. It exists, just hasn't been in one package. Sentence. Why use more words when few do trick, Core? It exists, just hasn't been put on the one package. Yeah, I mean, yeah, but Core, you understand. I don't know why I do this. I don't know why I do this. You're telling me that, oh, well, Skylon's engine is almost there, even though it's never been employed in a package. But you're sitting here looking at an RS-2200 that's definitely been test fired. Like, no. Yes, Blues. Yep. Voyager 2's launch vehicle is the miles per gallon champ. Yeah, but a lot of the